morning students. Today in our class we are going to see some numerical problems in projectile motion. Okay. First one. Four bodies A, B, C and D are projected with equal velocities having angle of projection 15 degrees, 30 degrees, 45 degrees and 60 degrees with horizontal respectively. The body having the shortest ranges, that is, it is given there are four bodies, all are having initial velocities equal, then they are having different angles of projection. For which body there is a shortest range? Okay. We are having u constant for all and acceleration due to gravity g is constant, those two parameters, and the only other parameter is theta. Okay. Depending on theta we have to calculate. The formula for horizontal range is u square by g sin 2 theta. Okay. Then if we directly substitute for, that is the range for a projectile with 15 degrees angle is u square by g sin 15 to becomes 30. For 30 u square by g sin, for 30 it becomes 60. U square by g sin 60. For 45 it becomes 90. For 60 it becomes sin 190. All these are constants. We concentrate on these values. Half root 3 by 2, 1 and root 3 by 2. Root 3 by 2. Then by seeing these values, root 3 by 2 is 1.732 divided by 2. This is, it becomes 0.8. Still it is greater than this 0.5. The minimum is 0.5. Therefore we can tell that it is having angle of projection 15 degrees is going to have a short range. Next one. Two stones are projected with the same speed but making different angles with horizontal. Their ranges are equal. If the angle of projection of one is pi by 3 and its maximum height is h1, then maximum height of other will be, that is, two bodies are projected with same speed but making different angles, so that they are going to have same range. If the angles of projection, one of the angle is pi by 3 and its maximum height is h1, then what is the maximum height of the second body? Okay. Initial velocities or speeds are given as theta 1. It is the angle of projection. Here the range is constant. We have to find this. This is the height of the first body. What is the height of the second body? Okay. In order to have same range, we are having 2 theta, sin 2 theta. Okay. For the 2 theta, if we go above and below 45 degrees for theta, we are going to have same range. Okay. That we have to know that. Okay. Theta pi by 2 plus or minus theta dash, where this theta dash is away from this pi by 2. We have to go away or down by theta dash, or here theta dash, they had one angle they had given as pi by 3, that is 60 minus 45, 15. We are going to get this one. Okay. Then theta 2, the second one is the difference, that is pi by 4 minus pi by 2, that is 3 pi minus pi, or if you take LCM, call 3 pi minus pi, that is 2 pi by 12 or pi by 6. Okay. Then the second angle is pi by 6. Then we calculate heights. Okay, h1 u square by 2g sin square pi by 3. It is root 3 by 2 whole square, 3 by 4. This parameter is going to remain constant. Then second height u square by 2g sin square pi by 6. That is sin 30. Half 1 by 2 square 1 by 4. That is 1 by 4 remains u square by 2g. From this equation it becomes 4 by 3 h1. 4 by 3 h1 into 1 by 4. Where we are getting h2 is equal to 1 by 3 h1. Okay. Next problem. A number of bullets are fired in all possible directions with the same initial velocity u. The maximum area of ground covered by bullets is, that is, they are having a gun, they are firing in all directions, okay, with same initial velocity. Then, what is the maximum area occupied by that process? Okay, that is, see, here u and g are constant. So, initial velocity constant g at a place is going to be constant. Then, maximum we have to calculate for range maximum u square by g into sin 2 theta. 2 theta maximum is 1, sin theta maximum is 1. Therefore, area is equal to pi into our maximum square, pi into u square by g whole square. Next one. A particle is projected with a velocity u, making an angle theta with the horizontal. Okay. At any instant, its velocity becomes v, which is perpendicular to the initial velocity u. Then v is, that is, the body is projected. Okay, it is having a parabolic path. Then at certain point of its journey, its velocity is perpendicular to initial velocity. That is, if it is going up, it goes like this. While coming down, it is going to come like this. If it should be perpendicular to this initial velocity, then the condition is, see here, we first resolve these velocities into two components. Initial velocity u cos theta I cap plus u sin theta j cap along I direction, x direction and y direction. Then the second velocity v at any instant, v cos theta 1 cap, the theta is changing from time to time, v sin theta 1 j cap. Okay. Then in order to have a perpendicular to the initial velocity, okay, it should happen while it is falling down, because the horizontal component, the vertical component is having like this. At the initial height, it is going to be 0. That is, from initial point to topmost point, it is going to undergo a change of 90 degrees. Then the initial is not a horizontal one. That's why they are not perpendicular. Then while it is coming down, it should be perpendicular to initial velocity. That's why, see here, for v perpendicular to u, if u is in the upward direction, not exactly upward, okay, then in the downward direction while it is coming. That is, we have to consider negative value. Theta 1 is equal to minus theta 1. Then if you substitute these values, v u cos minus theta is cos theta, v sin theta minus v sin theta 1 j. Horizontal component is constant. That's why this horizontal component is u cos theta 1 to I minus. This is the final expression. Now, v perpendicular to u means the dot product is 0. That is, see, dot product is 0 means we have to multiply these two. U square cos square theta minus uv sin theta 1 should be 0. The sum of these two. Then v u gets cancelled. Then we get v sin theta 1 u cos square theta by sin theta. Call it as 1. Also, we are having horizontal component. Okay, this one is equal to this one. V cos theta 1 is equal to u cos theta. Equation 1, equation 2. V sin theta 1, v cos theta 1. Squaring and adding v square into sin square theta 1 plus cos square theta 1 v square. U cos theta is constant. It is common in both these two things. Then 1 plus, there is one more cos here. For that one, we have to square that one. Cos square theta by sin square theta. 1 plus cos square theta by sin square theta. That is sin square theta plus cos square theta. In the numerator 1 by sin square theta. It becomes cot square theta. Then b becomes u cot theta. Okay. Next one. The range of the projectile launched at an angle of 15 degrees with horizontal is 1.5 km. The range of projectile when launched at an angle 45 degrees to the horizontal is, okay, when launched at an angle 15 degrees it is 1.5. What is the range when it is projected at an angle 45 degrees? Okay, R15 is, that is launched at 15 degrees. 1.5. 45, what is the range? Okay, R15. U square by G sin 2 theta. 2 into 15, half is 1.5. Then R45, when it is launched at 45 degrees, U square by G sin 2 into 45. Sin 90 is 1. There is no need to have this one. Then we have to find U square by G. From this one, if we send this to the side, it is 3 km.